Using Biot-Savart law to find the magnetic field at distance p from a long stationary wire carrying current I. In this problem, we have to find the magnetic field at a point P due to a long current carrying wire. From the figure, it is clear that the current is in this direction from, let's say, x-axis to y-axis. And here is a point P at which we have to find the magnetic field. First, we will take a current element which is del L. Now we will join this del L to a point P, so it will becomes a position vector R. Now we will join the point P to a current carrying wire, so it will sort of a perpendicular, and as a result we will get a right angle triangle. This perpendicular distance is represented by, let's say, A. This angle is 90 degree, which is in front of the hypotenuse. This angle is pi, which is spacing the perpendicular distance of a triangle. And this is the angle theta, which is in front of the base, which is A. So to find the magnetic field at a distance p from a long current carrying wire, we will use the Biot-Savart law, which is equal to del B is equal to mu naught divided by 4 pi I del L sin theta divided by R square. This is the mathematical form of Biot-Savart law. Now we have to find del L, sin theta and R. In order to get the magnetic field at a point P, we need the value of del L, sin theta and R square. So here we have mentioned that sin theta is the angle between del L and R. So sin theta actually is the angle between del L and R in the Biot-Savart law. Now from trigonometry, we know that the sum of the sides of a triangle is equal to 180. So here sum of the angles of the triangle is equal to 180. 180 is equal to 90 degree plus theta plus pi. So here we have 90 degree theta and pi, which is equal to 180. So in order to find the value of theta, we will shift 90 degree to the left side of the equation. So it will become 180 degree minus 90 degree is equal to theta plus pi. Now we have to find the value of theta. So we get 90 degrees equal to theta plus pi. Now taking sine on both hand side. So sine to the left and to the right will be equal to sine of 90 degree is equal to sine of theta plus pi. So the equation becomes sine of 90 is equal to sine will multiply to theta as well as pi. So sine theta plus sine of pi. Sine of 90 degree and the sine of theta will sine of pi will move to the left of the equation. So sine of 90 minus sine of pi is equal to sine of theta. Now we will take sine as a common and we will get 90 degree minus pi. So it will be equal to sine of theta. Now we know that sine of 90 minus pi and sine of 270 minus pi will change into cos of theta from the pure mathematics. Now sine of 90 minus pi will be changed into cos of pi, and the sine will remains sine of theta. Now sine of theta will equal to cos of theta. This is equation number 1. Now we have to find the value of R. So in order to find the value of R, we will take the right angle triangle in which we know that cos of pi is equal to base divided by hypotenuse. So the base here is A and hypotenuse is R. So cos of pi is equal to A divided by R. So by rearranging this equation, we will get R is equal to A divided by cos of pi. So this is equation number 2 and this is the value of R. So now we have to find the value of L, or we can say the value of del L. So in order to find the value of del L, we will take this right angle triangle again and we will have to find the value of del L. So we know that the tangent theta is equal to perpendicular divided by base. So this is perpendicular and this is the base, so the tangent pi will be equal to perpendicular divided by base, which is then equal to tangent pi r L over A. So by rearranging this equation, we will have A tangent pi r is equal to L, or L is equal to A tangent of pi r. Now we know that if we take the derivative of this equation, we will get del L is equal to A secant square pi r d pi r. So this is equation number 3. You see here, if we take the derivative of tangent theta, then we will have secant square pi r or theta in a result. So by putting these values of equation 1, 2 and 3 in Biot-Savart law, we will get the magnetic field at a point P due to this current element. Now we have del B is equal to mu naught divided by 4 pi r I dl sin of theta divided by r square. So by plugging the values, we will get del B is equal to mu naught divided by 4 pi r I, and instead of del L we will put its value, so it will becomes A secant square pi r del pi r, and instead of sin theta we will insert cos of pi r, and divided by r square will be A divided by cos of pi r whole square. Now del B is equal to mu naught divided by 4 pi r I A secant square pi r del pi r cos of pi r divided by 1 over cos of pi r whole square multiply A whole square. So we know that 1 over cos of pi r will be equal to secant of pi r. So the equation will becomes del B is equal to mu naught divided by 4 pi r I secant square pi r del pi r cos of pi divided by secant pi r whole square times A square. So this A square will cancel out with this A, and we will left with only A. Now del B is equal to mu naught divided by 4 pi r I secant square pi r will be cancelled out with secant square pi r, and we will left with del pi r cos of pi divided by A. So del B is equal to mu naught divided by 4 pi r I del pi r cos of pi divided by A. Now taking integral, because this is the del B is the magnetic field of the current element at a point P. So in order to find the magnetic field of the whole current carrying wire at a point P, so we will take the integral of this equation. So the integral will cancel out with this del, and the B will be equal to mu naught divided by 4 pi I divided by A. These all are constants, so we will move this from out. So the integral pi r 1 to pi r 2 will apply on del pi r cos of pi r. Now B is equal to mu naught divided by 4 pi r I divided by A integral pi r 1 to pi r 2 cos of pi r del pi r. Now if we take the integral of cos of pi r, we will get sin of pi r. You see, integral of cos of pi r is equal to sin of pi r. So this is the formula, right? Now applying the limits, so B is equal to mu naught divided by 4 pi r I divided by A limit of sin of theta from pi r 1 to pi r 2. Now we have to understand that if the current carrying wire is very large, so in this case we will have pi r 1 and pi r 2. So by applying the limits, the equation will becomes B is equal to mu naught divided by 4 pi r I divided by A sine of pi r 2 minus sine of pi r 1. Now sine of pi r 2 is 90 degree. You see, from here 0 to 90, and then from here 0 to 90. So this 90 will be minus 90, and this 90 will be plus 90. So by putting the values in this equation, we will get B is equal to mu naught divided by 4 pi r I divided by A sine of pi r 2 will be equal to sine of 90, and this minus is in the limit, so we will left it as it is, and sine of pi r 1 will be equal to minus sine of 90, because this is from 0 to 90 but in the negative quadrant, right? Now B is equal to mu naught divided by 4 pi r I divided by A, and sine of 90 will give us 1. Minus and minus will be plus, and sine of 90 again will give us 1. So 1 plus 1 is equal to 2. So the equation will become B is equal to mu naught divided by 4 pi I divided by A times 2. So 2 will cancel out with this 4. So 2 1s are 2, 2 2s are 4. Now B will be equal to mu naught I divided by 2 pi A. So this is the magnetic field at a point P due to a current carrying wire, right? But this case is when the point P is in the middle of the long current carrying wire, right? If point P is at this location, right? If point P is at the one side of the wire, then pi 2 will be equal to 0 and pi 1 will be equal to the 90 degree. Under such condition, the magnetic field will be different, right? And by applying the pi 2 in this equation 0, so sine of 0 will give us 0 and minus will be minus, and this sine of 90 will be, sine of minus 90 will be 1. So minus will be plus and this will be 1. So under such condition we will have magnetic field is equal to mu naught I divided by 4 pi A, right?